Hey guys, so today we are gonna discuss about this problem here. Prove that the gravitational potential due to a circular disk of uniform surface density sigma and radius a at a point on its circumference is minus 4g sigma a, where g is the universal gravitational constant. Now we have to draw the disk first. This is the circular disk. I have drawn it pretty big for you to understand, and this is the center, and this is radius a, and this is also the radius a. Now we take a point a here, as we have to calculate the potential on any point on the circumference, and we have to draw these two lines of length r, and both are equal length, both has equal length, and this is the arc length. Okay, and this is also theta angle, this is also theta angle. Now I will change this theta a bit, so this will become like this, and this will be d theta, and the arc length will change like this. And here if this is the r, and then this line will be r plus dr, and now this shaded region will have mass dm. So we have to calculate the potential on this point due to this strip of mass dm, and then we will integrate for the whole disk. Now potential at this a point will be minus g dm by r, and now the question is saying that the disk has uniform surface density sigma. That is, for this strip we can write sigma is equal to dm by dA. Now then, from this relation we can write minus g sigma dA by r. Now we can write this dA, that means the area of this strip, that is the arc length into the breadth. Okay, so the arc length will be here from this relation, s is equal to r theta, that is s is the arc length, r is the radius, and theta is the angle. Here the arc length will be this r is the radius, and 2 theta is the angle. Okay, so r 2 theta, and from with this we have to multiply the breadth. Okay, that is dr. Now this and the r will be cancelled out, minus g sigma 2 theta dr. Now here are two variables. Okay, theta and r, both are variables. So if we try to integrate this now, that will be very hard. So we'll integrate this, we'll replace this variable with theta terms. Now how? We'll see. If this is the radius a, and this will be radius a. Okay, so and we will draw a perpendicular like this. So these two triangles are equal, we can see that. Okay, so this hand and this hand will be equal to, so if the length of this hand is r, and this the length will be r2, so capital R, so this small r consists of two capital R's. Okay, so now we have to measure the value of this capital R, and that will be from this here, this is theta, so we can write a cos theta. So smaller will be 2a cos theta, so dr will be minus 2a sin theta d theta. So we will use this relation in this line, and that will be like dVA is equal to minus g sigma 2 theta minus 2a sine theta d theta, and that will be 4g sigma a theta sine theta d theta. If we now integrate this, the limits will be like this. It will be like 0 to VA, and this will be 90 degree to 0 degree. How? Here, when this theta becomes 90 degree, the arc length will be like this, something like this. Okay, then as the angle reduces, the arc length will be like this, and when the angle becomes 0, arc length will be like this. So here, this way we can cover the whole disk. So the limit will be this, and we will do, let I is equal to theta sine theta d theta, and from the rule of partial derivation, from the rule of by parts, we can do this like theta sine theta d theta minus d theta. So this will be, we will get this using the rule of by parts. So if we put these limits now, this will be like when upper limit is, we put this upper limit here 0 0, and when we put this lower limit here, this will minus 1, this will be equal to minus 1. So we can put this value here, and we'll get VA is equal to 4g sigma a minus 1, that will be equal to VA, so minus 4g sigma a, and we had to prove this, so it is proved. Hope you understood it and enjoyed it. If you have any question, you can comment me below, and if you like this video, please subscribe, like and comment for these kinds of problems and discussions in future. Thanks.